Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from May June 2023 paper 2. In today's lesson, we will talk about question number 17 and question number 18. As always we will discuss these questions in detail so you can improve your conceptual understanding of photoelectric effect and also conceptual understanding of stationary waves. Let's study together, let's improve together. Question 17 says the diagram shows the energy levels for an atom of hydrogen. An electron is in the minus 13.6 electron volt level of this atom. A photon interacts with this electron. Explain why this interaction causes the emission of another photon. So first of all, let's try to understand what question is telling us. It is given to us that electron is in this energy level, mean at this energy level. So this one is our electron. A photon of light is coming and this photon is absorbed by this electron. As this electron will absorb photon, it jumps to another higher energy level. Now this electron here, it is in excited state. So this electron here is now in excited state. And this electron will not stay here for long because excited state is unstable state. And everything in the universe just wanna be stable. As human beings, we just wanna be stable. So these electrons, they also wanna be stable. Means everything in the universe just wanna be stable. Then what this electron will do and how this electron can be stable, this will just jump from higher energy level back to the ground state. Then when this will jump back, it will emit another photon, and this photon will be the same if energy difference is the same. So these are the points we need to write down for the answer of this question. Now let me show you the answer, how you can write down your answer. In your answer you can mention these 2 points because this question has 2 marks. So we can say electron moves to a higher energy level when it absorbs photon, because it is given to us a photon interacts with this electron. So it will absorb this energy and it will go to the higher energy level, and when this electron will de-excite, it drops back and release a photon. So this question has 2 marks. These 2 points you need to mention in your answer. Part B says a photon has a wavelength of 218 nanometers. Determine the energy in electron volts of this photon. So simply energy of a photon, this is equal to hc divided by lambda. H is a constant and its value is 6.63 times 10 to minus 34 joules seconds. And C is also constant and its value is 3.0 times 10 to 8 meters per second. Lambda, value of lambda is given to us 218 nanometers, so 10 to minus 9 meters. If we solve this one, we will get 9.12 times 10 to minus 19 joules. So this is the answer in joules, but we need to convert this one into electron volts. So we can say 9.12 times 10 to minus 19 joules. We want our answers in electron volts. So here we need answer in electron volts and we need to get rid of joules. Now we need to understand that 1 electron volt, this is equal to 1.6 times 10 to minus 19 joules. So we have 1 electron here, we multiply with 1 electron volt, so we have to divide by 1.6 times 10 to minus 19 joules. Now if we solve this one, we will get our final answer 5.70 electron volts. So this is how you can convert. So joules and joules will be cancelled. This is our final answer in electron volts. And this question has 4 marks. So if you have written all these steps, you will get 4 marks. Second part says explain whether the atom of hydrogen could emit a photon with this energy, means delta E equal to 5.7 electron volts. In order to answer this question, we need to understand one very important point. We need to understand delta E. It means that difference between energy levels, difference between energy levels are discrete. That's the main point they are asking you. Difference between energy levels. Energy levels are discrete. That's the point you need to understand. This is the main concept. Between energy levels are discrete. It simply means that if electron jump from this energy to this energy level, it can only emit one photon with certain amount of energy, and that energy is unique. Every time photon will jump from this energy level to this energy level, it will emit photon with energy difference equal to 13.6 minus 3.4. So we can find the difference. That will be equal to 10.2 electron volts. 10.2 electron volts. We can also take an other example. Let's say one electron jump from this energy level to this energy level. Every time electron will jump, the amount of energy it will release, that will be equal to the energy difference between these two energy levels, and that is discrete value, means always we will get this value. Now if we look at energy levels of hydrogen atom, so we can get this photon, but we cannot get 5.7. If you look at these energy levels, if electron jump from here to here, we will get 3.40, and if electron jump from here to here, we will get 13.6. we will get, in this case, this will be 13.6 electron volts, but we cannot get 5.7. so it simply means that hydrogen atom cannot emit photon of 5.7 electron volts. So these are the points we need to understand. This question has 2 marks, so simply in our answer we can mention these 2 points. We can say, as no energy difference between energy levels is equal to 5.7 electron volts, so not possible for this photon to be produced, because difference between energy levels are discrete. They are discrete, they are not continuous. So these are 2 very important points about this spectrum, means about these energy levels. So we have to be very clear how to answer this type of problems. Part C says photons with energy 1.63 times 10 to minus 18 joules are incident upon the surface of a metal plate. The metal surface releases electrons due to the photoelectric effect. Calculate the maximum possible speed of the electrons, and work function of the metal is given to us. So first of all, simply we can sketch this one. So you can imagine this one is the metal plate, and work function of this metal plate is given to us. That is equal to 5.89 times 10 to minus 19 joules. And you can also imagine photon of light is coming, and energy of this photon of light is 1.63 times 10 to minus 18 joules. Question is asking us, what is the speed, maximum possible speed of photoelectrons emitted from the surface? So we need to calculate what is V max. In order to answer this question, simply we need to use conservation of energy, or we can say Einstein's photoelectric effect equation. So simply we can say, in this case, energy of the photon, this will be equal to the work function, means the energy required to release electron from the metal, plus the kinetic energy maximum of photoelectron. So we can calculate first of all kinetic energy maximum. That will be equal to energy of the photon. So this is energy of incident photon minus work function of metal. So we have energy of photon, that is 1.63 times 10 to minus 18 joules. You have to be careful with units, and work function is 5.89 times 10 to minus 19 joules. If we solve this one, we will get 1.04 times 10 to minus 18 joules. So this is kinetic energy of photoelectron, maximum kinetic energy. Now we can write on here maximum kinetic energy will be equal to 1 half mv max. This is the speed of photoelectron, and this is equal to 1.04 times 10 to minus 18 joules. We need to calculate V max. So simply we can multiply this with 2. So we have 2 times 1.4 times 10 to minus 18, and we need to divide by mass of electron, and mass of electron is 9.11 times 10 to minus 31 kgs. And if we take square root of this one, we can find the speed, maximum speed of emitted photoelectron, and that will be equal to 1.5 times 10 to 6 meters per second. So this is our answer, and this is how you can approach this type of problems. And this is a typical question about photoelectric effect. So this equation is very important. You need to understand this is energy of photon, this one is work function, and this is maximum kinetic energy of emitted photoelectron. Second part says explain why the photoelectric effect demonstrates light behaving as a particle rather than a wave. Very basic question, but also very nice question you need to understand about photoelectric effect. Let's try to understand this one step by step. First of all, imagine that we have a metal plate, and work function of this metal plate is phi, and threshold frequency is f0. Now if we shine light on this metal surface, let's say frequency of EM radiation is f, and if f is lower than f0, there will be no emission of photoelectrons. Now if we increase the intensity of incident light, still there will be no emission of photoelectrons. It doesn't matter what is the intensity of EM radiation, means what is the intensity of light. If you go on increasing intensity of light, there will be no emission of photoelectrons. This is one of the reason photoelectric effect demonstrates light behave as a particle, not as a wave. If light behave in this case as a wave, so electron, they will accumulate energy and there will be emission of photoelectrons. But this is not happening. So that's the reason photoelectric effect demonstrates light behave as a particle. And the second thing we can understand is, now imagine that we have this metal, work function of this one is phi, and threshold frequency is f0. Now if we shine light on this one, and frequency of this EM radiation is f, and if f is greater than f0, there will be emission of electrons without any delay. There will be no delay and there will be emission of electrons. And the third point we can understand, now imagine that we have this metal and it has work function phi and threshold frequency is f0. Now if we shine light on this one with frequency f, and if f is greater than f0, there will be emission of photoelectrons. Now if we go on increasing this frequency, kinetic energy of emitted electrons will go on increasing. And if we increase the intensity of this one, intensity if we increase, number of emitted photoelectrons will increase. So if we increase intensity of light, and if frequency of the light is greater than threshold frequency, number of photoelectrons will go on increasing. And this is against wave theory of light. And so these are the points we need to understand. If these points are clear to you, now we can write down an answer. This question has only 3 marks, so you can write down these points in your answer. So in your answer you can mention these points. First point, you can say photoelectrons are emitted instantaneously without any delay. If frequency of incident light is greater than threshold frequency, as we discussed in the second part. Photoelectrons are not emitted with increasing intensity of light if frequency is lower than threshold frequency, as we discussed in this part. increasing frequency above threshold frequency increases energy of each individual photon of light that causes an increase in kinetic energy of photoelectrons, as we discuss here. So these are the points about photoelectric effect you need to understand, and these are some very important points to understand photoelectric effect and also to understand why light behave as a particle, not as a wave. Question 18 says the photograph shows a musical instrument called a violin. The violin has 4 strings. Each string is held in a fixed position by a peg end at the bridge. When a string is plucked, a stationary wave forms on the string. For part A, explain how a stationary wave forms on the string. So first of all, we need to understand what is a stationary wave. Stationary wave. Stationary wave is the resultant wave. In a simple language, we can say is a resultant wave of 2 or more waves. So in this case, there will be one incident wave. We will say incident wave. When we will pluck the string, we will produce one incident wave, and that incident wave will travel. At the end, it will reflect back. And when incident and reflected wave, they will meet, they will form a stationary wave. So we can say incident wave when superposed with reflected wave, stationary wave will form with reflected wave. And this question has 3 marks, so we can mention these points in our answer. In our answer, we can simply say incident wave is reflected at the end, and reflected wave superposed with the incident wave and form a stationary wave. So this is how stationary waves are formed. Part B says the simplest stationary wave that can be formed on the string has a node at each end and an antinode at the center as shown in the figure. The frequency of this wave is called the fundamental frequency. The strings on a violin have different frequencies, different fundamental frequencies as shown in the table. The tension in one of the strings is 71.5 newtons, and the length of that string is 32 centimeters, and the mass per unit length of the string is given to us. For this question, we need to deduce whether this is string 1, 2, 3 or 4. So in the table we have fundamental frequencies, so we need to calculate the fundamental frequency of the string, and then we can figure out that string. So how we can calculate fundamental frequency? Fundamental frequency F. In order to calculate F, we need V is equal to F times lambda. V is equal to F times lambda. So simply we can say F will be equal to V divided by lambda. If you look at this figure, we can find out value of lambda because the distance between 2 consecutive nodes is equal to lambda by 2, and this is equal to the length of the string, means this is equal to L. So from here we can say lambda, this will be equal to 2 times L, and length of the string is given, that is equal to 32 centimeters. So simply we can write on here lambda is equal to 2 times 32 centimeters, so it is 0.32 meters. Now simply we need to find out value of V. If we have value of V, we can find the frequency. In order to calculate value of V, we have to use V is equal to T, this is true for the string, means the tension in the string, divided by mass per unit length of the string. So it is given to us tension in the string is 71.5 and mass per unit length is given, that is equal to 2.03 times 10 to minus 3. So we have to be careful with units and we have to take square root of this one. If we solve this one, we will get 187.7 meters per second. So this is value of V. Now simply you need to plug in here 187.7 meters per second. If we solve this one, we will get F is equal to 293 hertz. So this is 294, so it means string is number 2, string number 2. So the data given to us is for string 2. So this is how you can figure out. In physics, understanding of question is very important. If you have clear understanding of the question, then you have these formulae, you can use them and you can find the answer. So the answer for this question is string number 2. Part C says the stationary wave on the string causes sound wave to be transmitted through the air. Describe the similarities and differences between the stationary wave on the string and sound wave transmitted through the air. So here we have two types of waves. First of all, we can write down, we have the stationary wave on the string. So we can say stationary wave on the string. Then here we have sound wave. So we can say here we have sound wave. Now we need to understand these two waves, do they have the same frequency or not? For frequency, we need to understand frequency depends on the source. Frequency depends on the source. So in this case, source is the same. So they have the same frequency because we plug the string, that is the source. Then that is the source of stationary wave, then that is also the source of sound wave. So it means wave on the string and sound wave, they have the same frequency. So this one is the similarity. Now we need to understand waves on the string. Waves on the string are transverse waves because particles of medium will move up and down and we will travel forward. Angle is 90 degrees, so we can say waves in the string are on the string transverse waves, transverse wave. And sound wave is a longitudinal wave. So this is one difference. So longitudinal wave. So we can say longitudinal wave. And the second thing we need to understand, the speed of the wave. Speed of the wave. So we can write down v of the wave, speed of the wave. So simply we can say v of the wave means speed of the wave. Speed of the wave depends on two things. It depends on type of the wave. So we can say it depends on type of the wave and it depends on medium. Depends on medium. So here we have two different types of waves and also they have two different media. Mean they are traveling in two different media. Transverse wave is traveling on the string and sound wave is traveling in the air. So it means that they have different speeds. So we can say different speeds. So we can also write down speed here and their speeds are not the same. So they have different speeds. Sound waves, they are longitudinal waves, they transfer energy, but stationary wave, they do not transfer energy. We can also talk about that point. And stationary waves, the particles on the stationary waves, mean the points on the stationary wave, they do not have the same amplitude. But all the particles in longitudinal wave, they will have the same amplitude. So these are the points we can mention in our answers. So the first thing you need to identify what kind of waves are on the string and what kind of waves are in the air. And then if you got this point, then you can simply figure out how to write down a proper answer. A beautiful question, beautiful. Beauty is in the eyes of observer. How we feel about something. So try to feel physics, not just plug in numbers. I hope this question makes sense to you. If this is clear to you, now let me show you the answer. So in our answer, we can mention these points. So let me clear this one so it's easy to see. So these points you can mention. Similarity, so this is same frequency because source is the same. Wave have different speeds because they are traveling in different medium and also they are different type of waves. Sound waves have same amplitude for all points. Stationary waves do not have same amplitude. Sound waves transfer energy, stationary waves do not transfer energy. That's the reason we call stationary wave, because they do not move forward and backward. So we see them oscillating up and down like this. So they do not transfer energy. Waves on a string are transverse waves and sound waves are longitudinal waves. So these are the points you have to write down in your answer. I hope this question is clear to you, and I'm also hoping all the questions in this paper make sense to you. If these questions make sense to you and these questions are clear to you, please like and subscribe because your encouragement is very important. It takes a lot of time to make very nice video to simplify and to make it more understandable for you. So it takes a lot of efforts. So please like and subscribe. If you like and subscribe, that is your encouragement, and with your encouragement I'll spare more time and I will make better videos for you. And also, if you need more help and you're looking for extra resources, please join Patreon. On Patreon you can find worksheets, and also you can find notes. You can also find topic wise questions, and also if you have any questions you can leave your question in comments. And if you join Patreon, on Patreon also you can ask me questions 24/7. See you next video.